This stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, my name is Leandro Facchinetti. Let's write some code together, shall we? What we have on the menu today is my Moby Dick, my nemesis. We are doing this library to help other developers build better looking, easier to use JS effects, real-time audio processors in REAPER. And one of the most important things for me is drawing the waveforms of the sound. This is what it looks like right now. I don't like it. And I've been working on this for so many streams that it's not even funny anymore. But yeah, we need to improve on this. So what is the issue? Well, you can sort of see as the waveform is moving along, it's flickering on the screen. That's what we want to solve. And I could think of some solutions, some ideas that could help out on this issue. But I think there is a fundamental flaw in the way that I am going about this. So yet again, we are going to restart. It's like the 5th time I'm restarting this. We're going to restart with a different concept. Hopefully that different concept will make things better here. It will not flicker as much. And it will also have a nice consequence of being faster, because another issue that I see is that this effect is not doing anything besides displaying the waveforms, and it's consuming 0.1% of my CPU. Additionally, there is another problem that it's not a huge issue, but this new approach that I'm thinking about that we are going to start implementing today is probably going to address this as well as a nice side effect. So because of all these issues being addressed by the same solution, I think that this stands a chance of being a good solution. We'll see. We'll find it out together. So the third issue that I'm talking about, so the first issue is the flickering, the second issue is the CPU. The third issue is that the scrolling is not smooth. You can sort of see jumping around. You may not be able to see this on this stream because this stream is not at 60 hertz. It's not 60 frames per second, and I see my screen at 60 frames per second. But still, when you run this, you see it's sort of jumping around. And this is true of other effects like relimit. Also displays the waveform, and it also has this kind of flickering, jumping around sort of thing. If what I'm trying to build is not too far from what's here on relimit, by the way, and this is what it looks like right now. So of course we are not quite there, but you can sort of see even in this effect, and I checked this on Logic, the compressor has a waveform thing, and it also kind of jumps around like that. I think that maybe the solution that we are going to start implementing today will fix all of these 3 issues at once. Yeah, and we'll start after this. All right, so what is it? What is this solution? Let's start with the way that I'm doing things, because the solution is just a related approach. It's similar. So how are we doing things now? We have some code in the sample block. Oh, and Bo is here. Hello, Bo. It's going well. I'm iterating on the same thing over and over, finding better solutions. So I feel like, how is it going, you ask me? It's going well, but I'm not too happy with the fact that the drawing of the waveforms is so complicated. And the concept that I'm going to introduce today is sort of complex. It's not going to be a lot of code, but the concept behind it may be complex. I don't know. It may actually be easy. So let's go over how the waveforms are being drawn right now. I have some code on the sample block, which is the block of code that runs on as audio comes in on every sample. This code. And what the code does is it pushes a sample into this waveform data structure. The waveform data structure is a circular buffer that stores the maximum, so these values here up top, and the minimum, these values here below. And while I'm collecting the samples, I have this notion of slice. I slices each one of these little blocks here, each one of these rectangles. Each, well, I guess instant in time is one slice. But one slice does not correspond to one sample because I'm showing 5 seconds worth of audio here. 5 seconds is what? It's this many samples, 240,000 samples, and I don't have 240,000 pixels on my screen. So I will have to take some samples and collapse them into a single slice. And I just take the maximum sample, the minimum sample, so that I'm able to draw this blob. So that's what this code is doing right now. And this is not a lot of logic, but it adds up, because for every sample that comes in, I need to take all this. I do all of this. For every sample that comes in, I do all of this. I take the maximum, the minimum, and I check if the circular buffer is over, and I check if I have already gone over the number of samples in each slice so that I start accumulating for the next slice. All of that I am doing in the sample block. Then the GFX block is the thing that draws. So the circular buffer containing the slices is accessed at the same time by the sample block as well as the GFX block. They access the data structure at the same time. And one is writing, so the sample block is writing, while the GFX block is reading from the same data structure, from the same circular buffer. In fact, that actually reminds me that there is a third bug. Look at this here on the left. You see these glitches going up and down that don't really correspond to what's happening here. You know what? To make this clear as day, I will be silent for a moment and then I will click and you will see that the click appears here and then it sort of wraps back to the other side of the screen. Did you see that? You can sort of see as I'm speaking here. So the issue is that the sample block is writing into the data structure while I am doing the drawing. So the old data gets overwritten. This is a race condition, and it's sort of funny that it shows up this way. It's a visual indication that there is a race condition going on, and we always knew that that was the case. That's an issue, I guess, a fourth problem that I'm trying to solve with this new approach. This new approach should solve this problem as well. So the GFX block is reading that circular buffer containing the slices. So this is the code that does that. We wrote this yesterday. So it's reading over that and it's iterating over that and finding in each slice. It's sort of a similar concept. You know how samples are being collected into slices because we have fewer slices than samples. So we take the maximum and the minimum. We do the same for columns. So each column is literally just one column that I'm going to draw, one rectangle here that I'm going to draw. Each column is a collection of slices. I have like 8,000 slices, but I don't have 8,000 pixels across my screen. I only have so many pixels. So I take this down even further, and I take just the number of pixels on the screen and I iterate over that. Why do I have this two-step process? Well, because I don't want to collect all the samples. That would be just a waste of effort. So I want to collect slices, but I also don't know what the size of the screen is. I mean, my effects have a resizable waveform situation. So I have to collect pessimistically 8,000 samples, because if you have a 8K display, that's enough to fill in an 8K display. 8,000 pixels is enough to fill in an 8K display. So as a worst case scenario, I collect 8,000 slices, but then as the screen is resized, I have to do that thing again of looking at the maximum and the minimum of all the slices to compute the columns. That's currently how things are working. And Bo is asking if Juice has easier waveform drawing capabilities, and that's a good question. I was reading a book, I am reading a book, the Will Perkel's book on designing audio effects in C++, and in that book, there is a chapter about waveforms. So I had all this idea that I'm going to talk about today that is going to fix, hopefully, all of these issues I'm talking about. And then I checked the chapter on the book on the way about waveforms. I haven't really reached that chapter yet, but I skipped over and I looked at it, and it seems like it's the same concept he's using there. And I would not be surprised if Juice has some waveform drawing capabilities. Oh, it seems like I have been here before. And I guess it's called audio thumbnail. But there are no visuals. Maybe on the tutorial. Yeah, this sort of thing. So I guess what I'm building, it amounts to something like this, and it will be worth finish reading that chapter on the book to learn about what Will Perkel has to say about drawing waveforms. It will also be nice to look at the audio thumbnail class and understand how it works. But I suppose it's going to be a similar process. It's going to be a similar technique as the one that I sort of discovered by myself because of all these issues we ran into. And the whole process of discovering this by myself has been sort of entertaining, because I thought it was going to be such a simple thing, but to make it fast and to not run into these concurrency issues, it actually gets quite interesting and a bit complicated. So those are the issues. I guess there are 4 of them. The flickering on the edges, CPU use, scrolling is not smooth, and there is this weird glitch on the left. Most of these issues have to do with race conditions. The writing and the reading in the audio thread and the GFX thread that are happening at the same time, they make the screen not scroll smoothly, as well as this artifact. They are both because of the same problem. So, all right, let's talk about the potential solution that we are going to explore today. The idea is that I'm not going to store all the samples or all the slices in the audio. I'm not going to compute all the slices in the audio thread. The reason for that is that I want to reduce the CPU use on the audio thread, so I want to do less work on the audio thread. And also to fix this race condition. So I'm not going to compute the slices on the audio thread. The audio thread will have a single responsibility: to push the samples into a circular buffer. So I'm going to store all the samples into this circular buffer. But this circular buffer will be rather small. The GFX block will be responsible for reading this circular buffer that the audio thread is writing to. So there will be concurrent writing and reading into this temporary circular buffer, this intermediary circular buffer. And the purpose of this circular buffer is just to allow communication between the audio thread and the GFX block. So this is a small circular buffer containing just a slice of audio that is very short as we can make it. And the audio thread is only responsible for writing into that circular buffer. That will alleviate some of the CPU use, hopefully. Then the GFX block is going to read into that circular buffer, and it's only going to collect the samples that it has not seen yet. So currently, as it exists, the circular buffer has this concept of the write head. It's the position into the circular buffer, and we only access the circular buffer based on offsets of this write head. So you can look at x of n, as typically people write about this, so sample x of n or sample x of n minus 2, that sort of thing. So we can only access the current sample in the circular buffer, or 2 samples ago in the circular buffer, or 100 samples ago into the circular buffer, which is the sort of access that you need in the audio thread when you're doing things like delays. And that's mostly what circular buffers are used for delays, for algorithms that need look ahead, that sort of thing, where it makes sense to talk about, oh, look, it's dark. So it makes sense in those algorithms to talk about 5 samples ago or 5 samples in the future, that sort of thing. But that's not what we are going to do. The read head of this circular buffer is going to be separate, detached from the write head. So with the write head, we'll just keep circling around, writing into the buffer, and we'll forget about it. The read head will lag behind the write head, and the read head is on the GFX block. So the GFX block will be responsible for the read head, and the read head will be following the write head, but it will always be behind, but it will be following along, and we'll be reading into the circular buffer. And as we read on the GFX block, we rewrite this information somewhere else. So the GFX block will be responsible for doing the slices computation, for instance, taking the maximum and the minimum of a bunch of samples to compute this blob. So the GFX block will be responsible for that. And that's great news because it's less work for the audio thread. And it does make sense for the GFX block to do this work, since the GFX block is the client of this information, is the one that wants this information. So the GFX block will be responsible for computing the slices, taking the maximum and the minimum, which is also good news because it's work that is done less often, only 30 times per second. Great. So it will read that, and it will compute the slices, and it will store the slices somewhere. So that's part 1 of the solution. We are going to split the circular buffer into 2 parts. One that is only responsible for the communication between the audio thread and the GFX block, and a second data structure that is responsible for the slices, but it's completely managed by the GFX block. So that's part 1 of the solution. But I have another trick up my sleeve, which is this second data structure that stores the slices. We could have it as a sort of a circular buffer, and then we could draw it on the screen. Just like we are doing, we could use a similar code to loop over the circular buffer and draw that on the screen, draw the slices on the screen. We could do something like this. But I think that there is a smarter way of doing it. We'll see if this pans out or not, but I have a clever idea. The idea, or at least I think it's clever, we'll see. The idea is that instead of storing slices information into an array or a circular buffer, and then every time the GFX block runs, we take all of those and draw them on the screen as rectangles. Because that's a waste, right? This same rectangle that I'm drawing over here will be drawn over there a couple seconds after. So I'm redrawing the same shape over and over and over, which is not it's not the fastest thing to do. And also, it's the reason why we flicker so much. So there is the race condition that is making this artifact on the left, and that is making the whole form kind of not scroll smoothly. But there is the second issue, that once we draw on the screen, if we keep changing our minds and redrawing, and we are not careful about the off by 1 mistakes and all sorts of rounding errors, we end up with this flickering thing going up and down on the edges. So instead of storing slices into a circular buffer and then redrawing rectangles over and over on the screen, what we'll do instead is we'll compute the slice and we will immediately draw it, not to the screen, but to one of those different GFX destinations that we looked at in a previous stream. So it's another destination you can draw to. You can imagine this as an image that you can draw to, and it's a separate canvas, and then you can render this image into the buffer that we actually see on the effect user interface. You can render that image into the screen however you want it. So we will not be accumulating slices into an array and then drawing it. We'll be directly drawing into a separate canvas that will render on the screen however we want. And that has two advantages. The first, it will not flicker, because once we drew this, it just drawn. We may slide that around. That's something we may do. We may slide this around, but it is drawn. Once it's drawn, we'll not redraw it, which means that it will not flicker anymore, because it's the same image just sliding around. So that's part one. Part two of why this is a good thing is that we will potentially save even more CPU along the way, because drawing the rectangles over and over is a costly operation. You have to loop over an array, you have to do some computation, you have to call a primitive to draw. And with this new technique, we will only be rendering an image. Of course, there will be the work of drawing the incremental change since the last time we drew anything, but after that, it will be a single GFX blit to take that temporary buffer we are drawing into and putting it on the screen the right way. And there will be some extra work to make sure that we slice and dice everything correctly, and we'll have to take care of some concurrency issues here and there, but that's the general approach. So it's a two buffer approach. One of the buffers is a relatively small buffer. The audio thread writes into that. The GFX block reads from that. The second buffer is not a circular buffer. It's literally just an image on the screen that we draw in a smart way for the waveform to look like this and scroll around. And because the GFX block will be in control of this temporary image, it can scroll that smoothly. That's the plan. That's the goal. Before I make things better, I do want to explore something that will probably make things worse, which is in JS Effects, there is this notion of, it's a relatively recent addition to REAPER. There is this notion of refresh rate, and I want to look at that just to see if it helps anything or if it makes things worse. Maybe it's only in the changelog. Where is the changelog? REAPER changelog. Yeah, this guy. Allow override of refresh rate with options. That. Because that's something that is relatively new, and we haven't really looked at this, but for waveform displays, it makes a lot of sense. So I think all I have to do is just drop this here, but I will consult the JS Effects documentation real quick. No, not that part. No, that. And oh, it is documented. It's right here. Use spaces to separate multiple options. That was the part that I didn't remember. Okay, so probably we don't want most of these. Oh. This is interesting. I didn't know. Will only be called periodically and a UI will not be disabled. That's so smart. All right, but this is what we want. And it's relatively recent. Yeah, I think that we will use time precise to... So this is something that will come up. The timing of the scrolling is jumping around because it's dependent on the frequency with which Reaper refreshes the screen. So that's currently what's happening. And they say here that you should not rely on that. Even if you set a precise number here, you should not rely on that for the timing thing. You should rely on time precise. And I think that that's what we are going to do. So, right, let's reload the plugin and see if that looks any different. It appears to, yeah, it looks different. It's smoother. And I guess with this, it even highlights the issues of things jumping around and the smoothness of the scrolling that is not happening. The lack of smoothness, I guess. So yeah, this is a good option. I want to keep it. And there is no way for the library to opt into this, I don't think. But we can try. What if I make this a small number? Let's see what that looks like. Yeah, I can definitely see this jumping around. Which I guess reduces the CPU use, so it's not terribly bad either, but yeah, right, okay. But if I take this number and drop it into the library, can a library control options? That's the question, I guess. Can a library control options? And that's what we are about to find out. A library cannot control options. That makes sense. I would expect as much. So we'll drop this back here and make it 60 frames per second. And this is the sort of thing that will make this plugin incompatible with older versions of Reaper, but I don't really care about it. All right, so okay, I explained everything that I wanted to do. Now we are going to tear apart the code that we currently have, and we'll start implementing this new idea. That's the part that I sort of like doing, actually. It's the part where I take the whole implementation of all of this. So let's see what we have in terms of to-dos here. The contour, yeah, we are working on that. Stuttering, it's the issue that I mentioned where the scrolling is not smooth. And a way to control whether the waveforms reset on playback restarts, that's kind of a separate issue. So, well, the approach that we are taking is fundamentally different now, or the approach that we are going to take is going to be fundamentally different. So I think Aria tells me that I am an over leader, and I guess I am. Because I just deleted the whole implementation of waveforms, and we are going to start from scratch. And this effect, of course, is using the waveform, so it will not work for a while. Right, I have no expectation that I will be able to finish this today, but let's get started. What do I need in terms of the data structure for the waveforms? I don't really know, so I'll just say waveform new is a function that's currently empty, but I know I will need it, because I know I will need some data structures. So then I will have a function called waveform push, and that is responsible for pushing a sample into the circular buffer used to communicate between the audio and the user interface threads. So I'll take a waveform here as an argument, and I will need to write that sample. So I will need to receive a sample as well. Then I will have a function called waveform draw. That one will be called from the GFX block. And it will need a bunch of things. But for now, I don't really know. So start with that. Then, previously, we had these three functions, but the arguments are different and everything. So that's why I deleted the whole thing and rewrote. So here we had that notion of how many slices you would want. But now, the circular buffer used to communicate between the threads is independent of the number of slices you want. So I don't need that information here. I will need some other things though. Well, I need to have this circular buffer. So I will call this samples because it's a circular buffer with samples. So that's going to be position 0 in my waveforms data structure. And I do know that I will need other things. Yeah, I was thinking if I could have the waveform be just a circular buffer. The waveform data structure could be just a circular buffer. I don't think so, because I will need other pieces of data in here. So yeah, it will need to be its own data structure that contains a circular buffer. So now we need to think about, we need to create a local variable here. And we'll need to allocate this. So memory new of a single position for now, this position. And how do we initialize it? Well, it is going to be a circular buffer, but what size? That's something that we have to think about. What is the size of this circular buffer? Well, it's the circular buffer used to communicate between the audio thread and the video thread. So its size is dependent on the ratio of the ratio between when you run each one. So I could have this as a parameter, but I think I will try to just come up with a value that works. So the idea is that the audio thread, the sample block, is running like 48,000 times a second. So that's the add sample block. And meanwhile, the GFX block is running like 60 times a second. So that means that the sample block will have the opportunity to write into the circular buffer 48,000 divided by 60 times. So it will write 800 samples between the time that the GFX block runs once and when it's going to run again. So 800 samples will be written in that time. And of course, we don't want to cut this short, right? So because if we are off by just a little, if one video frame is dropped, whatever the case may be, we don't want to lose those samples. So we probably want to make this number higher. We can make the assumption that the refresh rate will be at most 60. If you want to go with 120, you can. All you gotta do is maybe have like waveform refresh rate. If you wanted to do a plugin that refreshes every 120 hertz, if you want to increase this number even further, then you will have to change this constant. It's fine. It is what it is. And this is just the sample rate. So I can just come up with this formula because 48,000 is my sample rate divided by the refresh rate. And if you wanted to change this number to go even higher, you would just reset this global variable before you, or this constant, before you call new. So that's fine. But of course, this is just too optimistic. If we drop any frames or anything, what happens then? So I guess I'm going to multiply by like, what would be a reasonable value? 10, I guess. So it means that I can drop 10 frames and then run again, and I will be fine, because I will have that information in there. And that means that typically for 48,000 hertz refresh rate or sampling rate, and this refresh rate, I will be storing 8,000 samples, which is what I was storing before, but it's even better because now I'm storing just samples, and before I was storing slices, which were maximum and minimum. So I was storing 16,000 values before, and now I'm storing 8,000. So that's a good amount, I think. So that's that. And naturally, I will need to return that. And then what happens when I am pushing a sample into the waveform? That's actually super easy. Because all I gotta do is take these samples and push into there. I think it's called circular push. Yeah, right, exactly. So I can just go into the samples circular buffer and push my sample. And that's all there is to it. So see how the audio thread is doing a lot less? That's exactly what we want. That's great news. Okay, so the audio thread is easy. Of course, the interesting part is the user interface, because it has to read all of that, and it has to be smart about the way it's reading it. But before I move on, I will commit this. So now we need to introduce another thing, which is there is this circular buffer, which has a write head, and the write head of the circular buffer is embedded in the circular buffer data structure, but we will have this special read head. Oh, and Bo has to leave. Okay, see you later, Bo. Looking forward to the end result. So am I. Really hope that this pans out. So we'll need another piece in here in the data structure, which will be the read head into the circular buffer, but it will be the read head that is not based on the write head. It's an independent read head. So I'll call this the samples GFX. I don't know, samples read head. How do I call it in the circular buffer? I call it the position. That's not the best name, is it? But all right. Yeah, it's not the best name. Let's rename that. I think that every occurrence of position will be here in the circular buffer. It is. So let's rename this. There is the length and there is the right index. Or maybe just right. Because it's you can sort of believe that it's going to be an index. No, that's not too clear, so I'll go with right index. So let's check if everything makes sense here. The right index begins at -1. So that's another thing that I was thinking about. In the circular buffer, is the right index the thing that the place where you have already written, or the place that you are about to write? Oh, and I will need to rename this in the tests if the tests make any reference to this. They don't, so that's okay. Oh, the tests are no longer here. The tests are here now. Here are the tests. I collocated the tests recently. Right, so yeah, so I update the right index and then I write, which means the right index is the place where I have already written, So you update it and then I write there. So the right index is where I have already written. And this will become important when we are writing the code below for the read head to always be catching up to the write head. So, and that makes sense because when we are getting, we want to get relative to the right index, right? We have this situation where we take the right index. Oh, maybe this can change. Yeah, let's revisit this implementation for the circular buffer for a moment. It's a slight tangent, but I think it will be worth it. So, hang on, there is something to be said about this -1 here. Because typically you want to read from the circular buffer before you write into the circular buffer. Otherwise, you're wasting an item. We talked about this before. So yeah, you usually want to write after read, which means that you will be calling get before and push after. Typically on the code, you'll be calling get first. Yeah, typically you'll be calling get first, which means that to begin with, it will be on this right index -1, and it shouldn't be. So we need to start at 0. That makes more sense. Then, when we try to get, we'll be in that position 0. If we try to do an offset of 0, it's fine. Oh, but hang on, we do wrap things around. So it will go to the end of the array, which is 0 anyway. So it doesn't really matter. I guess I will start with -1. Okay. No, I'll start at 0 because there is a weird edge case about the way that we are wrapping the minimum. So it's off by one mistake. It's complicated to think about. Yeah, but having the right index always in bounds makes sense because you will want to get based on the offset before you push. Yeah, right. Okay, so starting at 0 makes more sense. Now, here is just us updating the right head and then writing, which means that the right index is where you have already written, which makes sense because the offset is based on that. Okay, everything checks out. So we get this, and then this, I think I will rename into the read index. And naturally, I'll have to do that. But then that. And that I really like, how the read index is based on the write index, and that makes it everything very clear to me. Now, is there a reason for me to do this in 2 steps, or could I just wrap it around at once? I think I can. So that's what I will do. Okay. Hopefully the tests are still passing, right? No. The 1265. Okay, I just need to have something here. Second try. Okay, let's see. Circular buffer passing. Great. We didn't break anything. Awesome. And we mostly just renamed stuff, but you know, that's where bugs lie. Right, so what I'm calling the read head, I want to call the read index, because I called it write index. Okay, so all of that was just preamble so that we could get here. The samples is going to be at 0, and the samples read index is going to be in position 1 into this data structure. And then we will say waveform in position 1. That can start at -1. I suppose. No, because I will want to start by reading. So I will start this at 0 to avoid an off by 1 mistake here. Okay, and there is just the situation here that I want to check on the circular buffer implementation, because we will be accessing this circular buffer concurrently. So we need to make sure that everything is thread safe. So when we are doing the pushing, we update this right index before we update the value. And that was only a trick so that the value would be the return of the push. But I think we need to do it the other way around. And I will keep the return of the push being the value. But why do I do it the other way around? Because I want to keep the invariant that the right index is a place where we have written to. We update the right index, we write there, and then we store this in the data structure. Because below, we will be accessing this right index to check against our read index to make sure that we caught up. So I need to guarantee that when you write, so this line is not consequential because you're just writing to very old position. So if there is some execution here in between these two lines, that's fine. We are not too interested for the most part. And access in the audio thread will be synchronous because there is no multiple audio threads running at once. So that will be fine. Yeah, this order needs to be like this for that reason, which is kind of a subtle point, but yeah, it has to be that way. Okay, so man, this is getting complicated. Let's go to the waveform again. So the read index is going to start at 0. Now, when we are drawing, we will need to get this read index. And we'll need to get the right index as well. So I'll need to get the samples. And from the samples, I will need to get its length. And let's see if I get this circular buffer length. Yep, 5 occurrences means that it exists in the file, so it means that I got it right. Okay, so we got the samples length. No, we're not interested in the samples length. Or are we? Yeah, we'll be interested in that, but we will also be interested in the samples right head, right index. I will need to go there to the implementation. We have length and right index, like this. And then that. Okay. Now, we need to keep advancing this read index until we catch up with the right index. So, while I think so. While the read index is not the same as the right index, and I am making this on purpose. I'm making them different. I'm not making them less than or greater than because they will circle around. But I'm making them different because I don't want the read index to read what I just wrote. And it's an off by one thing. But, and I guess I am already safe because I made the thread safe change above on the circular buffer implementation, but still, I think that it makes sense for me not to try to get the latest sample. And it's like one sample, which is like 1/800th of a slice. It's no big deal to not read that straight away as it has been written. So while that is happening, I will want to update the read index. So I will need to do some circular counting. That will look something like this. And of course, this is based on the sample's length. So I sort of re-implemented the logic of updating the right index here, but that's necessary. It's a necessary evil for what we are doing. So yeah, the read index is now just catching up to the write index. What do we want to do in that meantime? What do we want as we are catching up? That's the drawing we want to do. Drawing. That's what we want to do. So we will need now to do that thing of taking the maximum and the minimum and everything. But yeah, let's see if we can do any sort of, I guess, just an example of to see if we are writing and reading the right way. Yeah. It will be just a very crude drawing thing. Well, let's do the reading using the read index. So how do we read using the read index? Well, the samples is a circular buffer, so we can just literally index into that. Nice. And I will call this the sample. Then, what do I do with the sample? I think that one thing that I can do with the sample, when I don't know what to do, I commit, I guess. So when I do, so what do I do with the sample? Oh, hang on. There is something smart I could be doing here, because this setup of incrementing the read index is at the end of the while loop. It could be in the beginning if I just subtracted one. And while I'm doing circular counting, even if the read index is 0, which will get us to -1. So if the stored read index is 0, which it is in the beginning, I will subtract 1, and the read index will be behind and then we would be trying to access that. So no, it's not going to fly. Yeah, it has to be this way. This update has to happen at the end, or at least that's the only way you can reason about it now. Right, so we do have a sample. What do we want to do with this sample? I guess I'll keep things simple. I committed because I wanted to write some code that I want to delete in the end. So I'll have a variable called x. It's going to start at 0. And I will have a variable called increment. It's going to be like 20 pixels, and then I will, or maybe 10 pixels. No, hang on, that's for a sample. So I guess I will have something like 1. Then I will get a hold of the sample, and then I will do GFX draw not GFX draw, GFX rect X, and then the Y position will be sample times GFX height divided by 2 plus GFX height divided by 2. Okay, that's silly. First of all, it's not called GFX height, it's called GFX age. So I just want to go to the middle of the screen. So GFX age divided by 2 plus, well, I guess it has to be this way. So the way it works is the Y position is go to the middle of the screen and subtract the sample times half of the screen. Okay, and what is the size of the rectangle? 10 by 10. And then I will also set this to white. And then on the waveform display, we have to revisit how we are calling all this. So we are creating one waveform drawing per channel. We don't need to specify the number of milliseconds. Then this sounds good. Pushing the sample is still the same. Background color is all right. Then there is a bunch of things here. Guess I will just comment all of this out for now. And then we'll call this with that. And how about we just do waveform 0, which is the left channel. Should be good enough for a test. So now this has a chance of displaying something. Let's check it out. Okay, it's not displaying anything, but at least it's not broken. At least syntactically it's correct. And the CPU is not any better. That's just underwhelming. But all right, we should see some variables like x. Oh, I forgot to increment x. That's an issue. Okay, I still don't get anything. Let's look at X to see if it's changing. It's not. It gives me the impression that we are not reaching here. Right? Well, let's just make all these variables global because we know we are only calling this from one place. So we can make these variables global, and I cannot comment in here. Is this not valid? JS effects syntax. It is valid, and now the variables are here. Okay, so now I can look at them. The sample's length seems all right, the write index seems all right, the sample seems all right, the read index seems to be catching up to the write index. Awesome. And every time I'm looking at it, it's actually caught up already. Oh, there is something that I need to take care of. I will need to update the read index at the end. I will want a line that is just like that, but in reverse. Okay. How does that look? Still the same. X is not incrementing. Hang on, I saw something. Okay, we are drawing now. But we're not, we are drawing something weird. It seems stationary. but it's not just a rectangle, so that's good news. I won't commit this because this is all just testing stuff. What are we drawing and why are we drawing this? I will reload the plugin to see if anything changes. Something changes. Let's look at the source for this. And I will keep this interface here on the side because in case it decides to draw something. But X is not incrementing. Well, how about we just draw the whole buffer every time? So all of this is just updating based on the read index and everything. So how about I move some of this code below? I will have a read index is equal to 0, and then I will do a loop that just looks like this. And this is, again, hacking together something to try to see something on the screen. I will want to bring down my X, and I will want to bring down all of this. All right, so my read index looks like that. Oh, I will also want to bring this down. So at that point, what am I doing really? Oh, because this is different. I will want this to be, yeah, so the read index is going to start at 0, and I will want to do the circular counter sample length, but I will want to do something like this. Okay. This is drawing something. This is drawing the circular buffer that is used to communicate between the sample block and the GFX block. So this is the amount of data that we are collecting to do that communication, and it seems to be working right. Now, of course, it's glitchy. Sometimes you'll see just a bunch of squares, and that's because of the race conditions, because I am drawing the whole buffer, not just the part of the buffer that has been updated since last time we checked, but it's doing something, and that's where we are going to stop. Tomorrow, I will be streaming with Aria over at IDGKG Sound, and we'll be talking about audio production. It will not be related to drawing waveforms on the screen. Then on Monday, we will also be on IDGKG Sound. I will be talking to Shua. Great fun. And on Tuesday, I will be back here to consume this data structure that seems to be working right and do some drawing. And this doesn't look too bad too. It's kind of artsy, so I kind of like it. All right, thank you all for watching, for joining me today on this ride, and I see you again tomorrow over at IDGKG Sound.